Hello everyone. Now in this lecture we will know about the next concept, that one is serializability under the database management system. In previous lecture we already know about the transaction, and under the transaction it's a concept of schedule and the type of schedule, that one is a serial schedule and the concurrent schedule. Now serializability means what? Now when multiple transactions are running concurrently, then there is a possibility that the database may be left in an inconsistent state. If the multiple transaction runs and because of the if the multiple transaction runs like T1, T2 both have different particular operations. Now the multiple transactions are running concurrently, then there is a possibility that database may left an inconsistent state. T1 update the A, T2 also update the A, or it may be the T2 again read B, T2 or T1 read the B, T2 read the C. It's execute concurrently, right? It may be the like this: T1 access A, then T2 access A, then T1 access B, then T2 access C. It's a concurrently process, like this reading of A, then T2 read the A. It's a concurrent. That's why it's a serializability is a concept that helps us to check which schedule are serializable. A serializable schedule is one that always leaves the database in a consistent state. If this one is a concurrent schedule, then we need to check it out. The particular schedule, consider this is the whole is one schedule, it's a S1. This schedule is the serializable schedule or not. Now we need to go with the how to verify or what is the use of serializability. Inconsistency in a concurrent schedule, we need to remove the inconsistency in a concurrent schedule. If we have a concurrent schedule, then we need to verify the schedule is serializable or not. Why? Because of serializable schedule is maintain the consistency of a database. Now the solution is a serializability. Now what is the serializability? Convert concurrent schedule into an equivalent schedule which has a serial order execution of its constitute in a transaction. Means if we have a concurrent schedule, then we need to convert that concurrent schedule in a serializable schedule. Then we can say that that one is a equivalent serializable schedule. That one is equivalent schedule which is a serializable. Concurrent schedule, then we create a new schedule, that one is equivalent schedule of this existing schedule. And for example, we create the one schedule, that one is this is the concurrent schedule, that one is we can say that the schedule 1. Now we convert this schedule 1 into the equivalent schedule of the S1. Now that one is we can say that is S1 dash, means this schedule is create the equivalent schedule of the S1, that one is the S1 dash, and which one is a serializable, schedule which is the serializable. If it is possible, we can say that such a concurrent schedule is a serializable schedule. If we can convert this S1 into a equivalent schedule, that is the S1 dash, and that one is a serializable, S1 dash is a serializable, then we can say that that is the serializable schedule for S1. Serializable schedule for S1. S1 is a concurrent schedule. Now this one is such a concurrent schedule is consistent and is free from the inconsistency problem. If the given schedule is converted into the serializable schedule, and that one is the equivalent schedule for the S1, then we can say that that is the serializable schedule for the given concurrent schedule, and which one is maintain the consistency. Now the type of serializability, it contains a two type of serializability, is a conflict serializability and view serializability. Means what is the serializability? We convert the concurrent schedule into the equivalent schedule, which one is the serializable, right? Why we want to convert the concurrent schedule into the serializable schedule? Because of serializable schedule is a consistent, maintain the consistent of the data, right? Or the maintain the consistency of the database. That's why we need to convert it. We need to verify the concurrent schedule can be converted into the equivalent of the that concurrent schedule. Then that equivalent schedule should be the serializable schedule, and then we can say that we can substitute, we can accept it. Now it contains a two type of serializability, is a conflict serializability and the view serializability. Now we will go with the what is the conflict serializability. Now the conflict serializability, a schedule is called a conflict serializable if it can be transformed into a serial schedule by swapping non-conflict operation. When we need to again know about the what is the actual the conflict operation, right? A schedule is called conflict serializable, means we have a one schedule, that one is, we need to check it, like we have a one schedule, it contains a T1 and T2 transaction, and this one is a schedule 1, right? Now when we say that this is the conflict serializable schedule, now we need to verify if it can be transformed into the serial schedule by swapping non-conflict operation. Means a schedule is called conflict schedule if this is the one schedule, we just do a make it as a serial schedule, means if this is operation A, now B, and it may be a C. Now if we convert this into a serial, means what? It is look like this, like T1, that one is A, then C, and then B. This is the serial schedule. This one is the concurrent schedule, it's a concurrent schedule. This is the serial schedule. By swapping non-conflicting operation, we swap this one with this one, right? Now we need to check this one is a non-conflicting operations. Now we need to know about what is the conflicting operation or the non-conflicting operation. Now two operations are said to be a conflicting if all conditions satisfy. Two operations are said to be a conflicting. If these conditions satisfy, then we can say that two operations are the conflicting, right? They belong to different transaction. Yes, C and B is belong to the different transaction. They operate on the same data, like read A, read B, read C. Now if we check B and C swapping, they operate on the same data item? No. They belong to a different transaction? Yes. At least one of them is a write operation. If we share read, B write and C read, one is write operation. A schedule is said to be a conflict serializable if one of its conflict equivalent schedule is serializable. Now we will go with the example. Two operations are said to be a conflicting if all conditions satisfy. Okay, all conditions satisfy. Two operations are said to be a conflicting, right? Conflict serializability. Then they belong to a different transaction. They operate on the same data item. At least one of them is a write operation. We will know this rule with a practical example. Now conflict equivalent schedule. If S is a S dash is a schedule formed after the swapping the non-conflict pair. Non-conflict pair. Okay. Now we need to know about the conflict pair and non-conflict pair. Then S and S dash are called conflict equivalent schedule. If we swap this and this, we can say that's this and this is said as the conflict equivalent. Means it's okay with the both process. Okay with the both process, right? It's a conflict equivalent. Means we just would change the position of this and this, and after that it's a accepting schedule. It's equivalent to the first one. Like it gives the output as a 10 and it also gives the output as a 10. Means it's equivalent. We swap the process but its output is equivalent. That's why it's a conflict equivalent schedule. Now what is the conflict pair and what is the non-conflict pair? This is simply the simple example to know about the concept. Conflict pair means what? That is the read write is a conflict. Why? Because of read A and write A. Okay, A is the considered as 10. Okay, and read A by T1 transaction 1 and write by T2. Now if when T1 read, A is the 10, correct? If T2 write, it may be it change the value of A to the 20, right? But if we swap, that is write A and read A, okay, means first this operation is happened, means it changed the value of A is 20 and then read A by the T1, that one is read by actual, it's a 10, but after the swapping transaction T1 reads it as a 20 value. Means what? It's a conflict pair, right? Read A, write A is a conflict. Again write A, read A is again a conflict. Then write A, write A is again a conflict. If we go with the all the operation with the same data, A, then we can say that this is a conflict pair. We cannot swap it. Right? Now with the reverse also it's a conflict, right? If we reverse it, it's again a conflict. What is the conflict pair? Pair which is not swap. Swap reflect on some value, that one is a conflict pair. Like when we swap it, it may be the without swapping T1 reads A value as a 10. After swapping, T1 read as a value as a 20. This is a conflict pair. It reflection with some value. Now non-conflict pair, then this is the non-conflict pair. Read A, read B. It's again the data is different, right? Data is different here. Read A, read B. Then read A, read A. No problem with the read A if we swap it, right? If read A by T1 and then read A by T2. If we swap it, it's no reflection with the process, right? If we mention here and this one is measure upside, right? Swap it, like change the sequence, like this one is first read by the T2 and then read by the T1. It's swap. Initially T1 read, then T2 read. Now T2 read, then T1 read. If we swap this, like this, it not reflect any change. That's why it's a non-conflict pair. Okay. Then W, this values are the different, right? Values are the different, A and B. That's why it's again the non-conflict. Again read A, write B. That one is again values are different. That's why it's again the non-conflict pair. This is simply the concept of conflict pair and non-conflict pair. Now, important point to note, we cannot swap the order of a conflict pair. right? If it is a conflict, we cannot swap it, because of it change the output. Now we can swap the order of a conflict pair. We cannot change the swap of the order of conflict pair. Finding a conflict equivalent schedule. Now this is simple example. Now we have this schedule initially. We can say that this one is a S1. Sorry, it's a S, right? This one is this first one is a S, and this one is a S dash. Now if read A, write A, read, then T2 read A, then T1 read B, write B, and T2 read B. If we swap between the read A by T2 and read B by T1, if we swap it, means we copy this operation after this read, right? It comes after this read. Now again we copy the read of A by T2 after the WB. Can it change the value of A by read by T2? No, because of both operation, both operation work on a B, and this one is a work on A. That's why we can mention like this is in a sequence of T1, and then we can give the access to the T2, right? That one is simply the both operation. This S and this S1 gives the same output. Okay, no reflection. That's why we can say that it's a conflict equivalent schedule of this S. Is a conflict equivalent schedule of this S. This one is S dash, right? Now the given schedule is the whatever the concurrent schedule. We check the serializability. Is a conflict serializable? Yes. Now we can say that the given schedule is a serializable schedule. Okay. Now in the next lecture we will know about what is the view serializability, and then we will know about if it is a not conflict, then we need to check the view serializable. If the given schedule is concurrent schedule is conflict serializable, yes, then we can say that the given schedule is a serializable schedule. If the given schedule is not a conflict serializable, then we need to again check the view serializability. If it is a view serializable, then we can say that it's a serializable, and if it is not, then we can say that it's non-serializable. We cannot change in a given schedule, right, to make it as a serializable. Okay. Now this one is simply the example of the serializable conflict serializable, and in the next lecture we will know about the view serializable with example. This is simply the concept of a serializability. Why we need to serializable the schedule? Because of the existing schedule is in a concurrent schedule, and we need to make it as a serializable, right? Then we need to find out the equivalent serializable schedule. It's such a possible, we can say that the concurrent schedule as a serializable schedule, then we need to apply these two, and we can say that that is a serializable. Given concurrent schedule is a serializable, but it comes with the two type, right? We need to know about the both types, and then we will differentiate these two types. This is simply the concept about the serializability and conflict serializability. Thank you.